In this tutorial, we're going to learn how to create and work with objects from classes that we write. To get started, let's right-click the default package, select New Class, and we'll name this class Classes and Objects, and click Finish. And as usual, we're going to create our main method by typing main, pressing Ctrl spacebar, and hitting Enter. In the last tutorial, you learned how to create or instantiate an object. In other words, you learned how to create an instance of a class. And it looked something like, for example, JLabel label equals new JLabel. So here, the class is JLabel, and we're creating an instance of the class by using the new keyword and calling what is called a constructor, and assigning that object that is returned into our label variable. So when this line executes, our label variable will refer to an instance of the JLabel class. A class is kind of like a blueprint for an object. You only need one blueprint to build a house, but using that one blueprint, you could build many roughly identical houses. It's the same idea in Java. Once you have created your class, you can instantiate as many objects as you want from the class, and each object will be independent of the others. So what do I mean by that? Basically, each object is able to have its own variables and methods, so changing one object doesn't change the others. The idea will become more clear as we work through an example. So for our example, I'm going to create an additional class by right-clicking the default package and selecting New Class. I'm going to call this class Person and click Finish. And now we're going to have two tabs open. This program will have two .java files. Now even though our Person class doesn't contain anything but public class Person, we could still create an instance of it just as we did with JLabel. For example, we could say person equals new person. And now our person variable will refer to an instance of our person class. And as I mentioned earlier, we can create multiple instances of the same class. So we could copy this line and paste it below, though we'll have to name the variables something different. And since person isn't particularly descriptive, let's actually give them names. I'm going to name the first person John and the second person Bob. So now we've created two person instances. The first one is referred to by our John variable, and the second one is referred to by our Bob variable. Now let's say we want our person objects to contain certain data about different people, such as their name or their age. Well, we can program that by going to our person.java file, and inside the class we could say string name, and that variable will store the person's name, and int age, and that variable will store the person's age. And now if we go back to classes and objects, after John is created, we could say John.name equals the string John, and John.age equals 20. And you'll notice that Eclipse now gives us the code assist feature when we type our variable name in a dot, and it tells us everything that we can do with our John object at the moment. We could do the same thing with Bob and say Bob.name equals Bob, and Bob.age equals 25. Now what we're doing here is we are directly accessing variables through an instance of an object. So we are directly accessing name and age through John, and then directly accessing those same variables, but for a different instance, through Bob. Now let's print out some of this data. So we could do a syso, Control spacebar, and we can say quotes, John is space, and we'll concatenate on John.age and concatenate on the string years old. So now if we were to run this, we'll see that John is 20 years old is printed out. And that's what we'd expect, because we assigned the value 20 to John.age. And we could do the same thing for Bob. We'll say Bob is Bob.age years old, and run that, and we'll see that Bob is 25 years old. So this shows that even though they are both created from the same class, the values are independent. In other words, in memory, John.age and Bob.age are entirely different. And now I can attempt to demystify this static keyword. If we were to go to person and change int age to static int age and run the program again, we'll see that John is 25 years old and Bob is 25 years old. So what happened here? When a method or variable is static, it basically becomes a member of the class itself and not an instance of the class. So where we have static int age will actually belong to the class person itself rather than an instance of the class. In other words, there is only one class person and there is only one age variable for the entire class. So no matter how many people we create, the age will always be the last value assigned to it, because there's only one variable in memory. Whereas the string name without the static keyword is what's called an instance variable. And what that means is there is one string name for every object that is created. So since we've created two different objects, John.name and Bob.name are different variables. But John.age and Bob.age, because we changed age to static, both refer to the same age variable. So if we remove the static modifier and run our program, it will be back to normal. So when we create an object, we do so by calling the constructor for the class, and we do that by using the keyword new and the name of the class followed by parentheses. And this part of it is called the constructor. And by default, Java provides us with a default constructor, but we can also create our own. So to do that, we can go back over to person, and to create a constructor, it's much like a method, except there is no return type. So all you would type is public, the name of the class, parentheses, and then curly braces. Now, whenever we create a person object, whatever is inside of the constructor will run. So we can see that by putting in a system.out.println and saying person created. So when we run our application, we'll see person created ran twice, which makes sense since we called the constructor two different times. Now because the constructor is essentially a method, we can pass data to it as we would with other methods. So we could pass it a string name, and then we could assign that passed name to our name variable. But right now that poses a problem because they're the same name, and if we say name equals name, that code doesn't really do anything. Eclipse even tells us the assignment to the variable name has no effect. But if we go back to classes and objects, here you can see that we referred to name by John.name. In other words, we have an instance of the class, and then a dot, and then the name of the variable. We can do the same thing from within the class itself, because once we run this method, we have an object created. And the way to refer to the object inside of a class is by using the keyword this. So if we say this.name equals name, now this.name will refer to our instance variable name, while this name refers to the parameter string name. And now if we went back to classes and objects, we no longer have to say John.name equals John or Bob.name equals Bob, because now our constructors expect that we pass them a string name. So for John, we'll pass in a string John, and for Bob, we'll pass in a string Bob. Now referring to John.age and Bob.age directly like this is considered bad practice. what people often do is generate methods called getters and setters. For example, if we went up to our label and said label dot and the word get, we'll see a whole lot of things we can get. And we type dot set, we'll see a whole lot of things we can set. So we'll follow that convention with our person object. So if we go back to our person.java file, we can actually get Eclipse to generate our getters and setters for us. If we go up to source, generate getters and setters, and just go ahead and select all and press OK, we'll see that all this code is generated for us. And if you look at what they do, it should make sense. GetName returns our name variable, setName assigns the past name to our name variable, getAge returns our age, and setAge assigns the past age to our age variable. So now we can go back to classes and objects, and instead of john.age equals 20, the correct way to do it would be john.setAge 20 and bob.setAge 25. And we can change our print lines as well. Instead of saying John is, we could say john.getName plus quotes is, and bob.getName plus quotes is. And now if we run this, we'll see that our output is the same as before. I'm going to get rid of our JLabel since we don't need it, and we can also get rid of our import. And let's do another example. Let's say I'm going to have John say hello to Bob. Now right now this method doesn't exist, but what Eclipse allows us to do is to write a method that doesn't exist yet, hover over it, and we can create method say hello to person in type person. And if we click that, Eclipse will automatically generate the method stub for us. So now we have this method that says public void say hello to person Bob. Well, let's change Bob to something more generic, just person. And inside of the method, we could do a systemout.println, and we could say getName, so the name of this person, plus said hello to plus, and now we're going to get the person that we passed in and get their name. Right now if we save it and run it, we'll see that John said hello to Bob, and I forgot a space in there, so let's fix that. And run it again, and John said hello to Bob. And we could do the same thing the other way. We could say Bob dot say hello to John. Now John said hello to Bob, and then Bob said hello to John. Now keep in mind that previously all of the methods we've written have been static. In other words, they've said something like static void, do something, or static string, whatever. But now that we're working with an instance of a class, the only time you would use the static keyword is when you want that method or variable to actually belong to the class itself rather than an instance of the class. So now you should have an idea of how to create a class that has instance variables and instance methods, how to create an instance of that class, and how to use that instance to access its methods. And one last thing we better fix here, since I did say it was bad coding practice to access directly like this, we should say john.getAge and bob.getAge. And run it once more just to make sure it works. And there you have it. Thanks for watching.